All right, welcome back to pre-calculus. So today we are going to be talking about graphs of other trigonometric functions. Let me go ahead and share my screen and have that happen. So today we're going to talk about secant and cosecant, at least at first. I'm going to check the time. All right. So the idea between a secant and a cosecant, all right, is that they are the reciprocal function of cosine and sine, okay? Don't let the reciprocal part confuse you. The co means the complementary angle, the CO complementary angle, because if we have, say we have an angle alpha and an angle beta, we have a 3, 4, 5 triangle, okay? And I take a look at what's the sine of alpha. That's going to be the opposite over the hypotenuse. What if I look at the cosine of beta? That's going to be the adjacent, over the hypotenuse. So beta, right, is 90 minus alpha. The sine and the cosine are the same ratio, okay? Same thing with secant of alpha, right? That's going to be the hypotenuse over the adjacent. And if I look at the cosecant of beta, that is the hypotenuse over the opposite. So that's 5/4. Okay. So the cos mean complementaries; they do not mean reciprocals. Okay. So you definitely want to remember that, and just remember the secant and the cosine, right? Those are reciprocals. So if I ask, like, what's the cosine of alpha? Right, that's going to be 4/5. The secant was 5/4. Okay. So just be careful about that. All right. Let's take a look at. Okay, so we're going to draw some of this in, and we're going to do some values here. Secant tends to be used a little bit more than cosecant. Okay, just like sine tends to be used a little bit more than cosine, but you know, it's okay. So here we go. We have x being let's go with, actually let's do cosine first, and then we'll turn to secant. Okay. So we have cosine of x and then secant of x, all right? So we'll have our typical R0, right? Our pi/6, our pi/4, our pi/3, our pi/2. Remember, these correspond to 60 degrees, 45 degrees. I'm sorry, not 60. What am I thinking? I saw the 6 and got excited. So this is 30 degrees, 45, 60 degrees, 90 degrees. Okay, we are measuring the horizontal distance. Okay, so at 0, cosine is 1, pi/2, right? The horizontal is pointing straight, or no, pi/6. And the square root of 3/2, square root of 2/2, square root of 1/2, and square root of none/2. Okay, secant is 1/this. Okay, this is square root of 2/2. I don't know why I wrote a 3. It's not square root of 3/3. It's square root of 3/2. All right, so the reciprocal of 1 is 1. This is going to be 2/√3, but remember, you don't want to have that going on. So this is 2√3/3. Okay. Square root of 2/2. Okay, reciprocal. This is 2/√2. But instead of that, I'm going to say this is √2 times √2. That's equal to 2 divided by √2. That's going to cancel and just get square root of 2. Okay. 1/2, reciprocal 1/2 is 2. And 1/, right, this is 0/1. If I do reciprocal, this is undefined. Okay. So if I go through, we just look at the first quadrant. Okay, from 0 to pi/2. Okay, we have our values here, right? There's our 1, Actually, we'll put this down a little bit more. Okay, so let's call this one here for 1.688.707. So cosine is doing something like this. Okay. See if I can make it a little bit better in the drawing. We're going to do Desmos in a moment, but something like that. Okay, now when it's undefined, it's 1 over 0. We're going to have an asymptote at pi over 2. Okay, 1 over 1, if I reciprocate that, that's going to still be 1, right? And then look at what's happening here. Okay, we do 2 root 3 over 3. What value is that? That's 2 times square root of 3 equals divided by 3. So this was a 1.15-ish, right? What's the square root of 2? You should know this one. Square root of 2, 1.4. Okay, 2. Okay, so these are getting bigger, okay, as we're getting closer and closer to pi over 2. So the secant value, okay, is actually moving up this way, right? And the same thing is going to happen. So I'm going to wave my hands at the rest of this, okay? So our cosine is going to be something that's too much. Okay, our cosine is going to be something like this. Right? So we have pi and then 3 pi over 2. Okay, and then we're going to crawl back up to 1 when we get to 2 pi. Okay, so just like where pi over 2 is an asymptote, this guy here, 3 pi over 2, this is also an asymptote. Okay, and we've drawn in our cosine, drawing in our secant. Okay, so reciprocal of -1 is -1, but it's going to get further and further negative as we get closer and closer to that asymptote. All right. So, and then up here, right? So you might think, like, is this discontinuous? Or it is, but you know, what happens after we get there? Well, the same thing. This graph goes on and on and on in both sides forever and ever and ever. Okay, so we have this waveform. Okay, with this parabola type looking thing up to infinity, one that goes down to infinity, one that goes back up to infinity, one that will go down to infinity, and so on and so on and so on. Okay, and that's what a cosecant, that's what a secant looks like. Okay, so what I'm going to do is I'm going to turn our page to this guy. Well, not. I'm going to turn it to the other guy. Desmos. Okay, let's click off of all of this. Okay, so we're going to say y equaling cosine x. Okay, and then we're going to say y is equal to secant. So you can see, like, this wave thing goes on and on and on and on forever. When we have our intercept here, that's one of our asymptotes. Okay, and this will go on forever. Let me go ahead and close in a little bit here, because all we did for our graph is I just cut it here, and we just have kind of like I just pretty much did these two parts here, right? This one to blue, and then this piece here. Okay, so that's what that's going to look like for secant, right? Now for cosecant, that is the opposite of sine. Okay. I promise I'll clean this up in just a second. Okay. So same with sine, right? When we get to sine 0, right? We get to 0, we're going to have a cosecant value. It's going to pretty much be a negative asymptote here, an asymptote that goes off to negative infinity. Okay. On the other side, it's going to be positive, right? And then back up to infinity, positive infinity, right? So we get to pi right here. Right, we get to pi. This value here for secant, or cosecant rather, okay, this goes down and down and down and down. Okay. And again, it's going to repeat over and over and over again. Okay. Cosecant is going to look a little bit nicer because it starts off with the asymptote at 0. Okay. So you can pretty much get like one waveform in the 2 pi, 0 to 2 pi sort of region. Okay. So it's going to look a little bit nicer, but it really is like cosecant, cosecant are very much the same. So cosecant is going to look prettier when you draw it by hand versus secant, which is going to look a little bit like, why is it in 2 parts? Okay, because they divide, that purple part is going to be kind of divided up into this purple part here and that purple part. Okay, so something to remember, something to deal with. I think I'm going to tackle tangent when we get there, so I'll give you a break for these. Okay. All right. So let's go back and let's look at some problems. Okay. By the way, everything else works exactly the way that it had been before. Okay. So cosecant, remember that's following very much. It's mirroring the sine. Okay. So the first thing I'm going to do when I look at these functions, like which one is it like? Like which one looks like a sine? This one. That one, right? B and C look like sines, all right? There's no phase shifts or anything. It's just got a 4. Well, sine, this looks like, to me, this looks like a negative sign, right? On part C, it looks like a negative sign. Part B, it looks like a positive sign. So I'm going to pick the positive one because I don't have a negative value here, and that's going to be my graph for cosecant. Okay. Idea. Okay. Check. There we go. All right. So first little part, we can do that. And if you're looking a little bit at this for, if you're checking your work with Desmos, okay, which I would actually recommend, or graphic calculator, like when you're first doing this, that's the appropriate thing to do, is so you can get a feel for like, what do these things look like? Okay. So for this one, okay, you have to remember, like, what's the reciprocal function of cosine? And that would be secant. Okay, so we have 2 cosine equals 0. Okay, we have 2 cosine x equals 0, and they're going to start asking us questions. But you have to remember, like, secant is the reciprocal. Well, don't do cosecant. Cosecant, that's the reciprocal of sine. Okay, so cosecant and sine are kind of related. Cosine and secant are kind of related that way. Okay, so you have to be careful about that because it's not the cos that are doing it, it's the reciprocals. Okay, so when cosine x equals 0, where is that? Where does cosine x equal 0? So I'll draw. Okay, where does cosine x equal 0? So what's cosine x? 2 cosine x look like? It's 2 pi. There's pi. Pi over 2. 3 pi over 2. Here's 2. Here's negative 2. Right? So we have here, 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 and here. All right. So when cosine x equals, when cosine 2 cosine x equal to 0, we're here and we're here. Okay. So my secant, not cosecant, my secant, that's where there's an asymptote there. Okay. Well, what happens with cosecant? I'm like, well, that's more related to sine rather than cosine. Okay, so here's 2 pi, here's pi, pi over 2, and 3 pi over 2, 2, 2. This is y equals sine, or 2 sine x. this is y is equal to 2 cosine x, right? So sine x starts off at 0. Pretend that matches up, okay? So when cosine is equal to 0, we're at pi over 2. What's happening with this? What's happening with cosecant here? Well, that's fine. It's just 1. Okay. So let's go into what we're going to be doing here. Identify which condition about x. Well, secant is undefined. Cosecant is perfect. Okay. The graph of secant has a relative maximum. Graphs of secants do not have relative maximums. Okay. First off, it's an asymptote, so that area for secant is undefined, so we don't do relative maximums there. Okay. And then secondly, like it goes off to infinity. We don't say it's maximum because we have to specify the point. And we can't say, well, it's at 0 infinity. Like infinity is not a number. We can't treat it like a number. Okay. Again, cosecant has a relative minimum at x. That actually is true. Okay. Because the cosecant, right, that looks like sine. Let's go ahead and is it relative minimum? I don't like the fact that they do this to you. Sorry, I really don't. Okay. So where cosine was equal to 0, what's going on with secant here? Cosecant rather. Cosecant, like the area around the graph for cosecant here looks like that, right? This is pi over 2 here. All the values around it are bigger. So that's why we call this a relative minimum. It's because we take a neighborhood, we take a grouping, a region around this point, all the other values are higher. Okay, that's what we mean by relative minimum. So yes, although I really don't like the fact that they introduced this to you right now. Okay, the graph of secant has a vertical asymptote. That's true. Okay, graph of cosecant, it does have a vertical asymptote, but not where this is true. Okay. Cosecant does not have a relative maximum because it does, but on the other side. Okay, like over here, this would be a relative max. It's not an absolute. Okay, it's not the biggest maximum. Absolutely, it's just the biggest maximum in relation relative to the points around it. Okay, so that's what we're going to see there. So it can have a relative maximum, but not where. Oh, wait a minute. Cosine x equals 0. There's 2 places where that happens, isn't there? So we should double check. Okay. Let's go ahead and make another look at it. Okay. So when we're at pi here, okay, that's an asymptote over here. Well, cosine equals 0, pi over 3 pi over 2, that is a relative maximum. Okay, I'm sorry. Again, it's relative to the places around it. Okay, so that would be a relative max. I'm kind of hoping I'm not reading too much into this because, yeah. And the secants are asymptotes here. Okay, cosecants are not. So let me cross my fingers and hope for the best here. Okay, I did not like it. Oh, cosecant. That's not true. Cosecant is undefined. Looks defined. I don't want to go through this list yet again. All right. I'm not happy with this problem. E and E follows directly from 2 cosine theta equals 0. Yeah, they didn't want me to go into the rest of that stuff at all. Okay, I'm so sorry. So they just want us to worry about secants. They don't want us to care about the rest of the stuff one little bit. So that was way too far into what they wanted. Okay, it's not necessarily untrue, but it is way too much than what they had wanted. So they just want us, if they say something about cosine, all they care about is something about secant. Okay. So you can pretty much ignore all that stuff that we talked about. Okay. All right, choose the correct graph with the function in the period. Does this have a period change? No, there's no B. Well, B is 1. Does it have a phase shift? No, it's just an X here. The amplitude would be 3, so 3 and -3. So I like the 3, I like the -3 here, I like the 3 and the -3 here, I like the 3s, I like the 3s. Okay, it's cosecant. What does cosecant look like? Okay, cosecant. Okay, looks a lot like sine. Okay, so here's 3. Here's -3. Here's my 2 pi. Okay, let's go ahead and make little colors here. Pop, 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 pop. What's this point? This point is pi, right? And we have, there's an asymptote here. This point is 0. Okay, so this is 2 pi. Sorry, it looks like a 6 to me. 2 pi, pi, and 0. There's the places where asymptotes are. Okay, so we want this one. Is it secant or cosecant? Cosecant. Okay, so I like, this is the graph I'm looking for. Okay, that's the graph I'm looking for. All right, so close, but no. I'm looking at this. This looks pretty good. Okay, kind of liking this. Pi over 2 to 3. Yeah, I'm kind of liking this a lot. Okay, so let's go ahead and pick this one and move on with our lives. All right, let's go to the next one. Okay, so here we have, right, consecutive. Okay, so we have a bunch of s. We have a cosecant. We have a phase. We have an amplitude, and then we have our period. Okay, so let's have a look. All right, so we're trying to graph y is equal to 3 cosecant of 3x of x over 3. All right, so amplitude is 3. All right, I learned this stuff. I don't think they liked having amplitudes with things that went off to infinity. So I never really got used to calling this an amplitude, but I think your book does, so we'll stick with it. Okay, but we need the period. Okay, now like sine, cosecant and sine both have the same basic period. Okay, so we're going to have a 2 pi over b here. Okay, so this is going to be a 2 pi over 1/3. So how do we do that? 2 pi divided by 1/3 is really 2 pi times 3, which is 6 pi, okay? We could also do it this way. Where do we start? We start at 0. Where do we end? We end at 2 pi. So we need x over 3 to be 0. What's x? And in here we have x over 3 equals 2 pi. What's x? X must be 6 pi. And then what we're going to do is take our beginning, or our end minus our beginning. So it's 6 pi minus 0. 6 pi is the period. Okay, so there we go. Oh, we need more. Okay, usually what we do for problems like this, we go ahead and we think about the sign and graph it because of that. Okay. What happens here with pi? Okay, so we have x over 3 equals pi. So x equals 3 pi. How about here? Pi over 2. We have x over 3 equals pi over 2. Multiply by 3, we get x equals to 3 pi over 2. And then what about here? We have x over 3 equals 3 pi over 2. So we're going to get x equals 9 pi over 2. Okay. So we go from 0. Here's 6 pi. Here is 3 pi. Here is 3 pi over 2. And then here is 9 pi over 2. Okay, 4.5 pi. And then what was our, this was 3, negative 3, wasn't it? So what I'm going to do is we're going to dot this in. Okay. So we're going to have our sign. Oops, down here. Okay, so here's our sign that I'm dotting in. Okay, where are the asymptotes? The asymptotes are where we said it was 0, right? Here's my asymptote. Here's an asymptote. Here's an asymptote. Okay, and when we graph our cosecant, right, we are going to be graphing, here's my relative min, right? We're going to crawl up this way, crawl up that way. Here's our relative max. So remember that even though the thing is facing down, right, this is increasing because it's a hard skiing thing. So we get to here, and then it is decreasing. So it's increasing, decreasing, even though the arrows are both pointing down. We don't care. We read it from left to right. So this one decreasing, then increasing. All right. So that would be my graph. Let's hope we can make something like that and connect here. All right. So my asymptotes are at 0, pi, no, 0, 3 pi, and 6 pi. All right. So what do we want to do? We want to draw 0, 3 pi, 6 pi. Okay. And we knew that there was a value here at 3 pi over 2, minimum 3, minimum negative 3. Okay. Asymptotes and 2 points, one on each side of the asymptote. Okay, I think that's all they wanted. It is all they wanted. Look at that. Okay. Glad they didn't make us do more. We could have. Okay, we picked, points in the first quadrant, third quadrant, and go ahead and graph those. So we have some other values. Okay. But they didn't make us do that, so we're good. All right. So check it. All right. Moving on with it. We have secant of 4 pi x. Okay, 4 pi x. So to draw the graph, 3 consecutive things. Let's work on that. Okay. Let's get rid of this Christmas tree of horror and make a new one. Okay, what are we going to have here? We're going to have secant of 4 pi x. Or secant of this. Okay, so like I said, usually we're going to go ahead and graph cosine of 4 pi x first. All right. Now, in this case, we need to know. We begin at 0. Okay, so 4 pi x equals 0. It's pretty safe to say x equals 0. Okay, what about at 2 pi? Okay, so we're going to say 4 pi x equals 0. So x equals, equals 2 pi rather, sorry, 2 pi. So we're going to say x equals 2 pi over 4 pi, right? We're dividing both sides by this. That cancels, we end up with half. There's no pi's. That's okay. Okay, the middle term, right? This was pi. So we have 4 pi x equals pi. Okay, so we get x equals pi over 4 pi, which is 1/4. Okay, halfway between that, okay, we're going to have 4 pi x equals pi over 2, right? It's pi over 2. So this is x equals, we're just going to take the reciprocal, so that's going to be pi over, and this is 2 times 4 pi. Pi's cancel, and we end up with 1 over 8, right? So we have 0, 1 over 8, 2 over 8, blank, 4 over 8. You want to take a guess? Okay, 3 pi over 8, or 3 over 8 rather. So we have 4 pi x equals 3 pi over 2. Divide both sides by 4 pi, so we get x equals 3 pi over 4 pi times 2. Pi's cancel, and we end up with 3 over 8. What did you know? All right. So going to graph my cosine function, right, because it's related to secant. Yep, secant. Did I have a? No, I just have one. Okay, I wonder what my amplitude was. Okay, we're going from 0 to 1/2. We have 1/4 here. We have 1/8. And here we have 3 over 8. Okay. Here's 1. Here's -1. Here's my cosine, right? Cosine starts up here. We have a 0, -1, 0, 1. So my cosine looks like this guy. Okay, so up. So now when I go to dot in my secant, okay, we'll use that one. Okay, we've got my asymptotes. All right, and now we're going to just dot in our values here. Right, so my secant is going to look something like this. All right. So that's the kind of drawing I want to recreate. Okay. So what kind of values am I going to need? Well, I'm going to go from 0 to 1/2. Okay, so let's go here. We're going to go from 0 to 1/2. So we're going to be here, 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 and here. Right? And that's my cosine. I can kind of look at this thing and see a cosine. Where we're going to have our asymptotes? Well, where the cosine was going to hit the 0. So I'm kind of looking at it like this. Right? And I'm going to draw my asymptotes there. Okay. We're going to have a couple of points. All right. And then we're going to trust and hope for the best. Be sure to follow directions. Oh, plot 3 consecutive. Oh, okay. Okay. Plot 3 consecutive asymptotes and 2 points, 1 on each side of the second asymptote. 1. Okay, I think now we're okay. Right, so they just, for some reason, they just wanted this to include this one. Okay, that's fine. All right. So check. Okay, we should be pretty good there. All right. Let's go ahead. We're going to get, no, okay. Let me just, actually, let me not. So what we're going to do is we're going to put an end to this for right now. And we'll come back and we'll, I think we might be able to finish these up. Okay, I just didn't want to make another hour-long video for us. So we should be okay. So we'll go with that. Okay, so I'm going to stop here and then we'll make the next one up.